And we are live. So hello, everyone. It's great to be here. And I'm super excited today. As always for these webinars, we do have a guest today. But today we have a very special one. So I'd like to introduce, who's sitting next to me, but we're going to put it on two channels, is our CTO and co-founder, Eric Fourrier. So Eric, I'm very excited to have you here. Welcome to the stream. Okay, so we're going to talk a lot today about detecting intrusions in our DevOps environments, and we're going to be talking about AWS Canary tokens. But before we do that, I thought, why don't we start by talking a little bit about GitGuardian, Stephen, as you're here, one of the founders. When did you create GitGuardian, and why was GitGuardian created?
Yeah, it's pretty a fun starting story. We started with my partner Jeremy Thomas. We have two engineers from Central Paris in France, so engineering school. And actually, at the beginning, GitGuardian was was a side project. So we were like two engineer data scientists. We come basically from a data scientist and data engineer background, and we wanted to do a project, basically have a lot of data and do stuff on code. And we started we were both like having jobs in different engineering position, data science position, and we knew there was like some issue with code security, and actually that credential leaking was one of them, and was a stuff that nobody really cared about at the time in 2017. And we decided to start like as good data scientists analyzing the fresh data and a big source of data, which was all the open source public code based on GitHub. And we started scanning this open source code for secrets. So developing at the beginning a few detectors, basically trying to detect AWS keys, Twilio, SendGrid credential, and so on. And actually, we were amazed by what we found on this public repository. We found tons of secrets with really high permissions, so a lot of admin Slack tokens, a lot of AWS credential giving access to the full infrastructure. So basically, it was root credential at the time. And I will say with our little side project, we found there was actually a huge issue in the industry, and there were a few solutions at the time, but really not any enterprise solution, and no solution that you could deploy at scale. You had Git secrets at the time, the beginning of Truffle, but at the time it was really a small project raising a lot of false positives. So we decided to start with that. And actually we started with pro bono alerting, mainly scanning GitHub. And each time we found a secret, we send an email to the developers that just leaked the secrets. And it's actually the first product we developed. And that's actually still running at GitGuardian, and everything started from that. And after everything grew really fast.
Okay. Black screen for everyone. Okay. Okay. So apparently we're having technical issue with disabling ad. Try disabling ad blockers, and then we'll see. Anyway, let's continue. All right, Eric, I'm sorry. This is the first time we've had this issue.
No worries. So yeah, I was saying we started with pro bono alerting. Like basically each time we found a secret in GitHub, we send an alert to the developer, and after everything went really fast. We create product for developers, so a free application where you can sign up, scan your repositories, the historical data you have on your repository, receive real-time alerts, add some features like be able to receive alerts on Slack, and have some configuration, a real web app. And after we developed the internal monitoring product hosted on dashboard.gitguardian.com, and yeah, begin our to sell our product to different companies around the world to be able to remove secrets out of code, detect them, do the remediation, and really try to do it at scale, because we really realized it was a problem that was like a problem for every company in the world, and especially large one when you have tons of repository, tons of secrets, and you really need some tools to put secrets out of your code.
So it didn't really necessarily start as the business that it is today. It started as kind of an experiment and then kind of turned into a much broader business. Okay. Well, let's get into the topic at hand, because we've used up a little bit of time, but just to let everyone know, as normal, we will have some prizes. Now, it might be a little bit difficult because we'll have so many people on YouTube, some people on Crowdcast, but I'll do my best. So participate. So I've enabled chat in YouTube, so you should be able to chat in there now. And I also chat in the Crowdcast. We'll do our best to keep across everything. And if you participate a lot, basically, if I see your name a lot, then you get a chance to win some Amazon gift cards. So make sure you participate in that. All right. I think we'll skip this part because we're running a little bit behind time now. But first poll that we have, if you're in Crowdcast, there's a actually, we'll just do this for everyone. We won't do polls. If you're in Crowdcast, let us know in the comments and the chat section. Do you currently use, or have you ever heard of Canary tokens? So do you use them currently? Do you have no idea what they are? Or do you know about them but aren't kind of currently using it? Let me know in the comment section, and be really interesting for us. But while they're coming through, we'll also start in kind of getting at the topic at hand. So the DevOps toolchain is really starting to become under attack. We've seen this a lot in some recent breaches. So let's just have a look at what the typical DevOps toolchain looks like. Now, it's comprised of all these different things, right? So when we plan our code, we're using Jira or some other tools. When we're writing our code, we're using tools like VS Code. We're testing it, we're packaging it, we need to secure it, we're deploying it, we're monitoring it. It's exhausting. So Eric, why do we need so many of these tools in our development supply chain?
Yeah, that's actually a good question. So as you know, I would say as you start as a single developer on a project, you're basically doing the product spec yourself. You are doing the architecture. You are coding the application. You are doing the test. You are deploying. You're creating the infrastructure and deploying your code. You are acting also as QA, like testing that everything works smoothly. But it's really like based around like scaling a team. So as you grow, as your company grows, as your engineering team grows, you need you will hire people, and you will hire people better than you to do each of these jobs, basically coding, testing,
right,
deploying, monitoring, and you will have each team will have its tools, its ownership, and what you need is really good communication between this team, and really a good communication between the different tools. They must communicate together with API, with different interface, and it's really now the challenge of DevOps, how to grow your team with more and more tools and have like a smooth communication between all of this.
Okay, so that makes sense. It's really becoming a part of enabling us to move faster as organizations, build better, more secure, robust applications.
Yeah, it's like a factory. It's basically like a factory. You add more. If you add more workers, you will add more machines. You will. It's like terrorism. Like you will try to find the best people to do a certain type of job and really scale this way.
So let's tell a little bit from a security perspective. What this means from a security perspective is we've seen recently, and we'll run through some examples where these parts of the tool chain, these products that we're using to basically build better code are being attacked. So like, why are they being attacked? Why are adversaries now targeting these tools to try and get into companies, as opposed to maybe targeting a company itself? They're now targeting the tools that company is using.
Yeah, as you said before, there are more and more tools, and actually it's the DevOps and the IT world and everything related to engineering and development. It's changing really fast. You have new technology, new tools, new way of doing things. So And as we said before, like we need a complete communication between these tools. You have more and more tools that needs to be interconnected, and there are newer and newer. So usually when you're deploying a new tool, a new feature, you are really focusing on building the stuff, and the securities comes after. So we have these new tools that some hackers will try to enter inside, and after really, because everything is interconnected in this DevOps toolchain, they will be able to move laterally and take control of the whole software development toolchain.
Okay, right. So it's a really critical part, and what you can do as an attacker in the toolchain is much more than getting into a specific area of a company. So
Actually, we are hearing of new type of attack every day. You have like, for example, in supply chain, you have like this new type of supply chain attack, typo squatting, or like people trying to steal credential from really popular open source project, and insert malware in this open source project, and after every company in the world will download this project, and this malware code will be able to run in the different part of the system, in a CI pipeline, in a server, like wherever this code is deployed, basically. And it's you have the same paradigm than in cybersecurity in general. It's way easier to attack than to defend. It's maybe 100 times.
Right. Yeah.
We can see that in GitGuardian. Like we protect companies with 10,000 of repository where we find 10,000s of secrets, and an attacker need only one secret with the appropriate permission to be able to move laterally into the whole code base, collect more secrets, and after have access to more part of the infrastructure. So it's a way tougher job for the defender,
right?
That for the attacker. And it's a paradigm, like a big problem. It's like really a huge issue, and it's really with this new configuration and tons of tools, really the attacker are really taking advantage of this.
Got it. So we're seeing this as a trend, right? This isn't just an isolated incident. We're seeing it, supply chains attacks in the news, lots. It's a buzzword. I don't know if anyone's been to any tech conference, any security conference. There's at least 4 talks on something to do with supply chain security at the moment. It's the hot topic. But this is really what we're talking about when it comes to that software supply chain, is targeting those elements of it. And one of the reasons why this is so scary is because it's largely out of your control. So I'll give you an example of Codecov, which happened last year. They were in that testing segment. So you back a couple of slides, there's that section for testing. So Codecov sat in there, helped test your application. We won't go into exactly what it did, but essentially this application was attacked. It was turned malicious, and everyone that was using it had a severe security vulnerability. So there was an exposed secret inside their official Docker image. That secret allowed the attackers to be able to edit the code and inject some malicious code. It was in a bash uploader script specifically. And then what happened was those attackers were then able to move laterally into the victim, so into the target company. So Twilio.com, Rapid7. But here's an example of why this is important. Here's an example of a supply chain attack. Now, what's critical is that the end victims in this, being those companies, HashiCorp, Rapid7, Monday.com, they have no control over the dependencies or their tool chains becoming vulnerable. So we all have these tools in our systems. We can't, or Eric, I'm not sure if you agree, but we can't necessarily guarantee that we won't be breached, that one of our tools won't be malicious. Would that be a fair statement?
Yeah, actually, I think it's a postulate that you will be breached. It's true. I think we are like in a recent report of the Lapsus group, has been known for like paying actually bribes to employee to get internal access. And I say it's you have so many tools, so many ways to get in, that at some point you will be breached. Especially you have like a correlation between the bigger is your company, the more tools, the more employees, so the more access points you have, and so you really need to know when and where your breach. Actually, it's becoming a real issue, especially for supply chain attack.
Got it. Okay, so now the good news is this is becoming mainstream. We're understanding this, and there are some ways to protect it. And one of those ways is being able to monitor. So that's really what we're going to talk about: monitoring our supply chain, specifically using Canary tokens, and we'll get into what they are soon. So how do we detect these intrusions? Let's say that a component in your development tool chain, so like Codecov in that testing area or anywhere else, gets turned malicious. How do you know that there's an intrusion? How do you know that you have a problem? So at the moment, there's kind of two core ways of doing this. Intrusion detection systems. These aren't particularly new. And there's network-based intrusion detection, and then there's host-based intrusion detection. So what can we talk about the difference of how these currently work and what they are, Eric?
Yeah, I would say the old approach, even now, I think a lot of companies are relying on basically putting agent anywhere in your infrastructure. It can be in your network, it can be in your servers, it can be on your cloud providers, it can be anywhere in your system, and these agents basically will log every action that is performed on them and send everything to what we call a SIEM, basically, a security information event management platform. And after you have these tons of logs, tons of information, and you rely on AI algorithm to be able to filter out on this big amount of data, like some pieces where okay, there is an intruder or somebody that's trying to breach my network, trying to enter in my host, but has a lot of actually cybersecurity product, and you have this curse of having a lot of false positive and creating a lot of fatigue, and that's one of the main issue of this approach, and especially when you're a small company, you can have even tons of data and not enough security engineers or logic to be able to filter out the real alerts from all the noise. And actually, that's one of the big advantage of Canary token. It's really raising alerts that are like true positive, because you know that somebody triggers the token. It's like not you really filter out a lot of noise, and
right.
It's really this big advantage that you need to have.
And so that's where Canary tokens can kind of come in, and a difference in those areas is kind of getting that understanding, that immediate understanding of when an intrusion is happening and what the attackers are kind of doing.
It's really a low-hanging fruit. I really like this idea. It's like a low-hanging fruit stuff you can implement in your own infrastructure and in your own workflow. It's basically like I'm putting my canaries everywhere, and I know when somebody triggers it can be still for positive. One of your employees just test it, but still, like, it's way in terms of volume. We are taking about maybe like 1,000 times less volume that like what you currently have in SIEMs. Well, actually, you will log every action performed by any user on any systems of your whole IT systems and infrastructure.
Okay. So now's the big announcement that we can make. So at GitGuardian, we do secrets detection. Obviously, that's probably what you know us for. We've probably detected some secrets in your repositories, and that's why you're here. But we're adding another tool to the toolkit, and that's Canary tokens. So we have an open source tool that we've launched today called ggcanary. So it's on GitHub, made public today. So very exciting about that we can finally have this project that we've known about for a while publicly. And this kind of works a little bit in reverse of what GitGuardian has been doing, because we've been trying to detect secrets in source code. And now we're giving you a tool to be able to put them there on purpose, essentially put them there on purpose. But that is for the purpose of trying to get an attacker to use them so that you know when an attacker has breached your system. So if we go back to some of those examples that we've been using, with Codecov, with these tools in in the supply chain. How do you know when a third-party tool has been breached? Well, you're probably going to find out because the attacker is starting to, is starting to try and attack you. So here you can add some tokens in to basically get them to trip up, and that's going to alert you to that process. So a really cool tool going in here. And this isn't, we're not the first ones to do this, but there are some reasons why we did it, and some reasons why you may want to consider using our project over others. So why don't you explain a little bit about how we're kind of operating in this, and the tools that it's built upon, and how can you start to kind of build these Canary tokens?
Yeah, so the I will say the main idea for ggcanary is for anybody in a few commands to be able to generate all the infrastructure required to actually create Canary tokens, monitor all the activity performed on this Canary token. So any calls that anybody will do on this Canary tokens, and after being able to redirect all these calls on any what we call notifiers or any alerting systems. It can be just receiving an email. It can be receiving a message in Slack saying, okay, this Canary token was used at this time as this IP. It can be a native webhook where you can integrate with your different themes, like it can be Splunk, it can be PagerDuty, it can be basically any tools that will handle security incidents and security alerts.
Okay. And I think that's going to be a key difference with a lot of people here is to, why if, Canary tokens have existed before, there's this free service that you can go to, why create something to do it? And one of the key reasons is that this is something that, you spin up your own infrastructure. So, but you control it, it's in your house and you can scale it how you want. And it's open source, so you have control over it.
Yeah, I think this is one, as you say, it is one part of the vision. So, and we have it from the start at GitGuardian, is to be able to show the value quickly with free projects, so you can start using it. But I will say what we really try to do is and what we have done with secret detection is be able to, for anybody to use it. So if you are a large organization with like 2,000 developers, you really want to shift left on your code security and your secret detection. So you want any of your developers to be able to use it and to put it in its own workflow. It can be in pre-commit, it can be in the CI, and I would say we want to achieve in the future the same for a Canary token. It should be used. Any developers that access to systems could deploy Canary token, and it's really actually Canary tokens are efficient if you are able to deploy them anywhere in your software development toolchain. It can be in every repository of your code base. It can be in your Docker images. It can be CI secrets. It can be as a Slack message, and it's really, I will say, educating people on that. Okay, this is useful, and we need to have a full coverage, and this is, I will say, really the challenge between having an open source tool and being able to scale it for companies.
Yeah, great. If you're wondering why we keep turning our heads to the side, it's because we're sitting next to each other, and I'm trying not to look at him, but it's so hard. But one of the components that this is built on is AWS. So at the moment, there's AWS Canary tokens. Why AWS? Why have we started with that? Obviously, we've released this tool early. There's more iterations to come, and we're going to do some demos of it. But why start with AWS?
Yeah, so as you said before, we are not the first to have this idea. Actually, one of the company doing Canary token, which is called Things Canary, that is actually maintaining canarytoken.org, supports a lot of different other canaries. It can be fake LDAP servers, it can be fake database services. So any type of, you can imagine any type of trap you want to use to trap an attacker or an hacker. But we really focus on AWS secrets because we really want to focus on securing the software supply chain and the software toolchain, and like from our experiences, one of the most used secrets engine and the most used solution of the secret detection is like, of course, like a lot of company, AWS is the most popular cloud companies out there, and we know that actually hackers will target this kind of secrets, and it's really this simple idea that like a lot of supply chain attack and a lot of attack now, the leaking a secrets is not always the cause of these attacks, but at some point when a hacker is going to target your supply chain and your software development tool chain, he will try to look for secrets.
Yeah, it doesn't necessarily mean that it's the initial access. Yeah. It doesn't mean, it could be, but that's going to be one of the steps. It's always going to be one of the steps because secrets are so critical. So this is a good way to trip them up because
exactly
an AWS key is juicy, right? I mean, that's a low-hanging fruit. There's lots of things that you can immediately do with it. So at least testing to see if it's valid is going to be one of those things.
Yeah, and another stuff which is really important is like hackers use the same tools that like the defenders, so they will use Truffle logs, they will use Git leaks, they will use GG Shield, and all these secrets engine they are detecting AWS secrets. And another really important component is that they are checking by default these AWS secrets. So they will trigger by default canaries, which is a really important step for us. And even a hacker will try to automate in any way. He wants to know what resources he can access with AWS.
Yeah. Okay. Excellent. Is there a vision in the future to have additional keys that we can check with Canary tokens, or are we just going to focus on AWS?
For now, I think for the SDLC, we could have used any other cloud providers key like GCP keys, Azure keys. We chose AWS because it's the most popular one, but for now, I think it's more like how I would say the challenge is more how to deploy it at scale than for us having multiple canaries, but it's definitely something interesting.
Got it. So let's just go through some of the kind of key benefits of using GG Canary. You've mentioned Things Canary. Someone in the comments mentioned that they've been using Things Canary. I've used Things Canary because I made a bunch of videos about what happens when you leak secrets using that. So why would a company? What are some of the benefits that we're trying to solve with GG? Why a company would want to use this project over another one?
So the big advantages for first is like open source are free.
Yeah.
So that's a big advantage, and you can actually with Terraform and a few clicks deploy your whole infrastructure. It's simple to deploy, simple to configure, and you can also integrate it natively with GitGuardian because basically you have full control over what are your canaries. And after what's really interesting is one of the issue of Canary token in the past is, as always, we have talked about it, is false positive. Basically, one of your employee or one of the security engineers saying, there is a secret in the code base, and just checking it, and by bad luck, it's a Canary tokens. And if you actually secrets detection engine is configured to catch this Canary token and knows in advance that they are Canary token, it will not check them, so you won't generate false positive. And also you can use, in the future, you can use also GitGuardian shift left logic to be able to deploy really quickly as these Canary tokens via pull requests in all of your repositories, or let actually every developer that has signed up to GitGuardian basically generate a few Canary tokens and put them in its infrastructure and its repos and its Docker images, any components he has access to.
Nice. So let's just, before we get into the demo, we're about to get into the demo now. Make sure you let us know. Send us a thumbs up or a message in YouTube or on Crowdcast so that we know that you're still there, paying attention. But before we get into the demo, let's have a look a little bit behind, what's under the hood going on here. How does this actually work? Now, it's important. maybe you don't need to know the intricate details of everything, but to have a conceptual idea of how this tool is actually working. So we have a diagram on here. I have no idea what's going on with it at the moment. Can you walk us through and explain how this diagram fits together?
Yeah, and yeah, to be honest, it's also one of the I would say more technical reason we chose AWS. It's also being able to natively implement with AWS component all the logic necessary to make it work. So actually, the architecture is not so complex. So you will define basically some fake user in the ggcanaries.auto.tf bars. Basically, it's your canaries. As we said before, you can add up to 5,000 canaries.
It's a lot. It's a lot of canaries.
Yeah, it's definitely
so,
a lot.
Scalable up to a large organization. If you're using
Yeah.
5,000 canaries, have them scattered around that much infrastructure.
And you can always ask AWS for more. It's just like actually AWS limits, base limits. And what will happen next is like we are basically all the Terraform code that is in the repo is designed to build all the infrastructure needed to basically collect every calls performed on these canaries that are basically sent to CloudTrail. And after CloudTrail will aggregate, and it depends here, we have a limitation. And every time it receives more than 50 kilobytes of logs or having a 5 or 10 minutes delay, it will create a file of logs in S3 buckets. And so AWS distributed file system. And each time we have a file created here, it will trigger a Lambda function that we actually designed that does, I will say, pretty simple but really efficient job. So it will look at this log file, look every calls performed on a Canary token, and for each of its calls, it will generate an alert to your notification, so to all the notifiers you have configured. So you can configure, if you have configured Slack, you will receive a Slack message. If you have configured an email alerting via SendGrid or AWS ECS, you will receive an email. So it's as simple as that. And you also, as we said before, you can configure native webhook. So you can basically integrate with any system supporting webhook receiver. So now mainly all security systems are supporting native webhooks. So pretty simple, pretty straightforward, and works pretty well.
Okay, well, why don't you prove it?
Yeah,
why don't you prove it? Why don't we take a look at the demo section now? So I'll give you a minute to.
I hope it works.
Okay, all right. We've already had the technical issues for today. You only get one technical issue per live stream, so it's done. It's done. All right.
Okay. So let's go. So small technical precision here. We have already set up the project. So I will just do a quick walkthrough. If you want to set up the project, what are the main steps? So we have currently a README that explaining pretty well on the ggcanary repository, but I will just walk you through the main steps. So usually you want to use a dedicated AWS account for this dedicated because you don't want to mix it with your other infrastructure. Of course, you really want to segment this account, call it like canary your org name.canary, for example. After you create the AWS profile, and after it's really, I will say, classic Terraform, you need to set up a backend where you will store your Terraform state, and the next step are basically like, so if I look at here, this is where I basically will put so all the configuration of the files. So here you have like the Terraform backend, and here you have a lot of secrets. If you want to play with it, is basically the Slack webhook where we will generate the alerts, and it's like here you will configure your Slack notifier, your SendGrid notifiers, like any notifier config you want to add. And on this other file, it's basically all the canaries. So I've like just like for the purpose of the demo, just put 2 canaries here, and after you just have to init to do Terraform init to basically set up the Terraform apply to create the all infrastructure that will set up everything we have talked about before, basically the Cloud Trail, the S3, the Lambda function, and all the logic between these components. And now let's play with the interesting part. It's basically the demo, and we'll try to be actually to think like a hacker or somebody trying to go inside the infrastructure. So I've set up a small demo folder here with a repo test. Inside this repo test, you have like AWS credential. Of course, these are one of our canaries, and we'll just try to scan this repo with popular secrets scanner engine. We can try with Truffalog. So
right now we're scanning this repository to identify any secrets that may be in there, and we're putting on the position of an adversary.
Exactly.
We've got a repository, we've downloaded it, and now we're trying to find sensitive information.
Yeah, exactly. So I'm just looking at one of the parameter to just with Truffalog be able to scan a file system. So I'm just like looking to scan everything in my repo test. So actually Truffalog just found an AWS secrets. So without surprise, is this one. And actually it has performed, as we said before, it has performed a validity check. So actually we will wait a little bit to see if it triggers when it triggers an alert to our Slack.
Could we do the same function with ggShield as well? You know,
so let's do the same with ggShield. So ggShield secrets scan pass. We had an option .r to be, so it's recursive, and here we will do demo repo test. And here exactly the same. Hopefully we detect also with ggShield the secrets with like different presentation. You can, for those who are really interested in some difference between how secrets engine works, Truffalog will focus on single match credential, whereas like ggShield will really try is able to catch multiple matches credential. And here for us, AWS secrets is the client ID and the client secret, and we always like consider it's both. And you can see here we have performed the validity check also, and that's it. So just waiting. We'll wait a couple of minutes to see if we have received alert. I will just also just show you for people that want to test the project. We have small utils here just to show you. So you can list your keys. You can basically list your keys here, and here you can see my 2 Canary tokens, exactly the same that the one I have put in the test repos. And I can also perform with ggcanary call actually a call on one of the tokens. So I have to specify which one, and you will see the difference. So here this function actually, which is basically here, will perform a different action. So usually secrets engine will try to perform a minimum call. So really just in AWS, it's AWS get identity, so not listing any resources, just looking, okay, to whom does this token belongs to. And here with the ggcanary call, it's really performing a common action, it's basically listing all US3 buckets. And we'll see what it generates, but just waiting for the alerts. I want to just look at a little bit more on how you add tokens. What's really interesting here, and I think it's it's one of the powerful features of AWS. You can basically add tags to your resources, and it's fantastic for a security team because you can add to 30 tags actually in AWS. So you could put here for each of your tokens, you could speak about, you could put logic about the team, so to which teams this token belongs if you have a large organization. So really a more role-based access control logic, you can put it there. You can put the source, so where basically you will put your Canary token. So the source here, I put a quick example with 3 tags. I want to deploy, it's a token I will deploy in my VCS, so in my code, in a specific organization name, a GitHub organization, for example, and in a specific repo. I could add a tag about priority or severity, saying, okay, it's critical project. If this project is, if this Canary is triggered, it's probably, it's really critical, and I will have a different routing logic. So you can imagine basically any workflow at this point with this tag. So now let's pray a little bit. Did we receive our alerts on Slack? So just like if we are looking up there, so what time is it? Yeah, I think it's basically our canaries. So you can see here what's really interesting. It's like for now we have 2 calls, so we are still waiting for the third one that we did with the script with generate call, and if we look just to.
And these calls, came from when we scanned for the secrets because they were validated.
Exactly.
And they were validated by making an API call. So this is essentially, we can put a hacker hat on. A hacker's found the repository. He's tried to scan it for these credentials. And when he's found them, or if the tools he's using it does it automatically, he's going to check to see if these are valid, if he can use them in an attack. And by doing that, he's just now alerted us to his or her, I shouldn't say his, I'm sorry, to their presence in our systems already.
Yeah.
That's cool. That's really cool.
Yes, exactly. And a small detail. So here you can see we log the time the time at the call was performed, the IP address, and actually what route, what was the call actually on the AWS key. So you see here it's both secrets engine are calling the same API route, get caller identity, which is the smallest, actually the one in AWS that has the smallest footprint. And here you can also see an interesting difference of way of working between the 2 secrets engine is if we do a quick call on our IP address, so you can see it's actually the IP address of our offices that you can find it here. And this is the truffle, actually the truffle log check, because the check is performed locally, and this one is with GG Shield, and because GG Shield works with a server, it's actually the IP address of the
right. So we can see the 2 different
server. Yeah,
the 2 different IP addresses. Yeah. So in the event that the attacker is doing this, we can see information about them to determine. That's going to help us determine if this is a false positive or something we need to really be worried about.
Yeah, exactly. It can be a common way in Canary tokens to exclude false positive is, okay, you try to identify what IPs belongs to your network, and some people try to exclude them. It can be a bad practice if actually hackers
are inside,
already inside and are checking your secrets from inside. But
yeah,
you can lower the priority, or you can definitely perform any kind of logic you want to.
Got it. Well, that's really cool. We have some questions coming in, but we'll just bring back the slides for a minute now. So Canary tokens can be deployed in many different places. Where would you want to deploy these to try and identify exclusion? What are some common places to?
Yeah, so the most common places like source control systems, like you want to. I will say now the code is the treasure for every attacker or every hacker. You will try to get access to your code, after scan it and find secrets inside, and after do lateral movement and go everywhere in your infrastructure. But you have other really interesting place to put them. You can put them in your Docker images, for example.
Right, we know from Codecov that's how that's how it was in the Docker image. So you could put them.
The real secret was in the Docker image. So if they had the canaries inside the Docker image, and the guy is doing a full scan, it will they would have known that somebody is scanning the actually Docker public images. Right.
Well, they would have got a notification to know that someone's trying to attack that secret. So they would have known that that's basically a risk.
You can put them in you could put them anywhere where like you have secrets involved. You can put them there in like the secret manager for most CI/CD pipelines to know if your actually pipeline is breached. You can even put them in your vault if you want to say, okay, if my vault is breached, it's really bad.
Worst case scenario possible. Really, the vault has been breached.
The vault has been breached. It's like you can put criticity, like the severity to critical and everything, but it can also trigger false positive. So you have to be careful on that. And after you can even put in on your personal laptop, in your Slack messages, in your Gist, in your Jira issues, like anywhere. Like
anywhere you think
somebody will try to scan for secrets.
And when you said at the start that you can scale this up to 5,000, that seems like a ridiculous number. But when you start listing all these places that can be, it's like, okay, maybe not 5,000 if you're not a huge organization, but certainly you can see where at minimum 100 of these secrets could be deployed in places where you want to know. So that scalability is important to be able to ramp that up. And here we kind of have some examples. This one of the Jenkins server of basically having a secret in our CI environment, and knowing that the attacker has compromised the Jenkins server. Similar to what kind of happened in Codecov, a little bit different. And now all of a sudden, as he's performing his execution of that, as he's trying to enumerate through what he can, he's tripped up, and now we're alerted. And he hasn't made it to the critical app. He hasn't made it to further critical application. He hasn't been able to move laterally. So quite important. Now we have a few questions. So if you're in Crowdcast, there's a Ask Us a Question button. A few of those found it's on the right of your screen. A little bit easier than just in the chat. But if you're on YouTube, if you have a question, I know there's quite a few of you on YouTube, then I'll keep an eye on that as well. So. Let's have a look at some of these questions. How do I get back to? Okay, here we are. Aside from using AWS keys, Canary tokens, what other AWS information might work well if tokenized? Well, maybe not just AWS, maybe just kind of other. Like there are some other infrastructures that could be tokenized. We mentioned.
So there are a lot of other stuff that could be working well, like a fake database or fake server is a great, like a fake EC2 machine or a fake MySQL instances. Everybody knows that database is our big target for hackers, because they will try to either ransom your data or like destroy everything if they're in a bad mood. You have a different list of honeypot LDAP servers. You have tons of different answers. Ton of different use cases. But I would say EC2 databases is still in the cloud. I will say space, but really interesting.
Okay, so we have a cool one here from Marina, which is, do you have any tips for making canaries more convincing? I like this, sir. I like this one.
It's actually a great question that I won't say there is a single answer to that, because I will say that the big assumption we are making is like the attacker will use automated tools to detect secrets. So basically, they won't really. I would say they will fall in the trap, and they will maybe know after the check saying, okay, it's weird, there is 2000 AWS secrets with no permission. And maybe at this point they will realize, okay, it was maybe Canary tokens, but at this point it's too late.
Right.
You have detected them. And there is an argumentation here is like, when I am a hacker, I'm seeing like I've triggered 2000 Canary tokens. Is it dissuasive for me? So basically, will I stop my attack because at risk of being catched? So you can actually see Canary token as a really powerful force of dissuasion. But the question I think is really important is like how you configure your secrets engine to not make it too obvious for the attacker, and also being able to exclude it from your secret scanner. So you have different methodology. For example, with GitGuardian, you can say, okay, a specific file extension is dedicated for Canary tokens, and I will ignore it, or a specific list of extensions or file types or file names. You can do common-based exclusion, so you can think of a lot of methodology. Personally, I recommend the native, actually for Secrets Manager, native exclusion is like, what are the canaries. So actually an attacker has no way to infer it is a canary based on the file name or a comment in the code or whatever exclusion you.
Got it. Now, here's a good question too. If we put a Canary token in our Git repository, will GitGuardian detect, will GitGuardian recognize them as exposed? So basically, is GitGuardian going to detect these Canary tokens if they're in our repository?
Yeah, actually, we are working on a features to allow list Canaries token and really recognize them natively as Canary tokens. But as I said, like as of now, you can still use some tweaking logic in GitGuardian saying, okay, we'll exclude this type of file names, and every canary will be put in these file names, or you use the ggIgnore stuff.
But eventually we'll be able to ignore them because we know that they're Canary tokens. But right now we will still recognize them as valid. We have another one. Are we planning on integrating this? Oh God, we have lots. I didn't realize we had so many. Are you planning on integrating this into the enterprise platform as well? Or is this going to be a standalone open source tool, or is it going to be kind of integrated into the suite of GitGuardian's enterprise tool collection?
Yeah, it's definitely something we are looking at, especially also analyzing the usage of ggcanary and how people think about this solution to actually be able to detect hackers in trying to enter your USDLC. But it's definitely something we have in plan, especially all this native integration to be able to generate Canary tokens directly from GitGuardian, auto-ignore them for the secrets engine, being able to deploy them at scale with pull requests, adding permission for developers signing up to GitGuardian to be able also to give them 5 canaries so they can deploy it anywhere you can think of any solution. So we are a deep believer of indeed being able to shift left with canaries, also saying, okay, it's a responsibility for anybody, any engineers of protecting, having this mission to protect the development toolchain and implement it in different areas.
All right. So we're coming to the end. We've got one last question, and then we'll announce our prizes. So what are the potential risks of false positive alerts from Canary tokens? So like how could that disrupt a security in your organization by having too many false positives coming from canaries?
Yeah, actually the security, the false positive in canaries comes from your internal developer teams, like just trying to test them. And as I said, you can implement some countermeasure, like having a tight integration with your secrets detection engine. You can have like IP address filters. You can do good education with your development and engineering team, saying, okay, guys, we have implemented canaries. This is the format, and you should not trigger them. It's more this kind of, but it's definitely something like doable. In opposite, I think when you look at SIEMs and systems like that, you have this trend to add more and more data to it. and it will generate more and more alerts, and it just, it's just systemic, and it's really hard to find a solution to it. Whereas when you compare to Canaries, it's like it's just like you can put stuff in place, and even if you have like people triggering them inside your companies and in your own engineering triggering Canaries, the volume will not be high. And you can also build, for example, Signal saying, okay, I've deployed, 1,000 Canaries. If there is 1 or 2 Canaries trigger, it raises a medium alert. But if, for example, there is 100 triggers triggered at the same time, I will consider that it as a critical alert, saying basically someone is testing them all at the same time. So probably somebody with bad intentions.
Right, yeah, because the likelihood is if you have these in a couple of different places, an attacker comes in, he's probably going to come into a couple of different areas, it's probably going to trigger multiple. That's a good point. I hadn't thought about that. All right, so we're right on the hour. So we do have some prizes to announce. I'll have to have a look and go through, but I will say congratulations to Paul P. So good job, Paul P. Words of how to do that, of how to validate. So Paul P, congratulations, you've won an Amazon gift card. And I'll have a look at the data because we're streaming on multiple platforms, and we did have to split up the audience a little bit. But thank you all for attending. We do apologize for the technical issues. I think it was on the side of Crowdcast, but we will investigate and hopefully we'll be able to get to the bottom of it so that in the future we won't have any concerns and issues going forward. So I'd like to say now, thank you, Eric. Thank you for joining me. I know it was a great conversation, and this will be available for replays for everyone else. Okay.
Always a pleasure.
So thanks everyone. Thanks for joining us, and we'll see you.